Hi there, this is Professor Eckhouse, and I'm going to talk today about solving equations with fractions. So we are going to start with translating sentences to equations and solving, but first we need to remember about the properties of equality. So if A equals B, if we start out with A equal B, whatever's on the left side equals the right side, then if we subtract something from it, then it will still be equal. If we add something to it, it will still be equal. Multiply something to it, it will still be equal. Divide from it, it will still be equal. As long as the thing we do on both sides is the same. So that is the property of equality that we use so much in algebra. All right, so these we're just going to translate and write as an algebra equation. We're not going to solve them quite yet. We're just going to look at translating. So pause the video and give these a try. All right, so x divided by 3 is 5. One way to write that, x divided by 3 is equals 5. But the other way we do it mostly in algebra is x divided by 3 like that is 5. All right, the difference of m and 10 is 12. M minus 10 means equals 12. 3/4 of, so remember of means times. So we've got 3/4 of x is 24. The quotient of p and 2/3 is 5/6. So the quotient of p and 2/3 is 5/6. Okay, so another way to write that, of course, would be p over 2/3 is 5/6. Okay, and the last one, the sum of 5/6 and x is 2 1/3. So the sum means plus, remember, means equals, so there's our equal sign. So the sum of 5/6 and x, 5/6 and x is 2 1/3. Okay, so this would be hard to do like this. You'd probably want to turn the right one into an improper fraction, so you can do the math. All right, so let's look at doing the math. So first we're going to look at determining whether a fraction is a solution. So we do this first every time because this is how you check your work. So yeah, remember that. Make sure you remember that in order to check, you have to put your solution back in. So the way we do that is to determine whether a number is a solution to an equation. We've done this before, so this is just a reminder. Substitute the number for the variable in the equation and then simplify both sides and decide if it's true or not. All right, so which of the following are solutions to this equation, and how many solutions does a linear equation have? So let's start with the second question. How many solutions does a linear equation have? Well, it only has one solution. So that means only one of these could be true. So think about this logically. What could we subtract from 3/4 from to get 1/4? So hopefully you see that the answer is 1. But if you did not, what you would do is plug in each one. 1/4 minus 3/4 equals 1/4. Well, is that even possible? No, it's not possible. You have 1/4 on both sides. You're subtracting 3/4 from one of them, but not the other, so it can't be equal. So that one is not equal. Negative 1/4, so not equal, minus 3/4, so I'm just plugging negative 1/4 in for x, equals 1/4. Well, negative 1 minus 3 is negative 4/4. That is negative 1. That is not equal to 1/4. So that one definitely is not. Okay, so let's move on. Solve equations with fractions using addition and subtraction properties. So these are just addition and subtraction. So I am going to rewrite these so that I can have n plus 7/15 and then a space so I can write next to it. Often I'll subtract from below, but these, because they're fractions, it's easier to see it right next to it. So I want the n by itself, so I'm going to subtract 7/15 from both sides. And I'm going to get, this is going to go away, and I'm going to get n equals 2 minus 7 over 15, which is negative 5 over 15. Well, that reduces. So we have how many 5s in 5? 1. How many 5s in 15? 3. And this is going to become negative 1/3. Okay? So n is negative 1/3. Now, if you wanted to check, of course, you would put the negative 5/15 in here. So you would say negative 5/15 plus 7/15 equals 2/15. Is that true? Yes, that checks. All right, so there's our answer right there. All right, next one. How would you solve that? Why don't you pause the video and give it a try? Okay, so I went ahead and rewrote it. I want the p by itself, which means I'm going to have to subtract the 2/3 from both sides. How do I know I subtract? Because it is the opposite of addition, right? It's what's going to get rid of it. So it's going to subtract out to make 0, and p is going to be by itself. And I've got 3/4 minus 2/3. Okay, so let me just write right here, 3/4 minus 2/3, and I'm going to have to find a common denominator. So the least common denominator of 3 and 4 is going to be 12. So I'm going to multiply this one. What do I multiply 4 by to get 12? 3, top and bottom. What do I multiply 3 by to get 12? 4, top and bottom. All right, so p equals, so remember that's what we're finding, we're just finding p. On the top of the first one, I've got 9/12 minus 8/12. So 9 minus 8/12 is 1/12. So p is 1/12. So now on this one, I would really recommend you just check this on your calculator. So to check this, you would say, well, p is 1/12. Okay, so 1/12 plus 2/3 equals 3/4. So these kind of problems, I want to see the work. I want to see what you did, but use your calculator to make sure you know that your answer is correct. Okay, so put this in your calculator and see if it really is 3/4. All right, so part C. Give this one a try. Okay, so I'm setting it up just like before. I want to leave a little room, but what's the opposite of subtract? It's going to be add. So I'm going to add 1/2 to each side, and it's going to cancel here. I'm going to rewrite this one and say negative 2 long bar over 3 plus 1/2 long bar over 2. All right, what is the least common denominator here? And of 2 and 3, so the 2 and the 3 is going to be 6. So I need to get 6 on the top and bottom here. I'm sorry, 6 on the bottom of both fractions. All right, so 6 I'm going to have to say times 2, and this one I'm going to have to say times 3. And I'm going to have p equals, so on the top of the first one I've got minus 4, negative 4 over 6 plus 3 over 6. So those are my two numbers. So I've got negative 4 plus 3 over 6, and that is negative 1 over 6. Again, just go back and check this on your calculator. Negative 1/6 minus 1/2, does that give you negative 2/3? Check it on your calculator. So put this into your calculator, especially on a, say, midterm. Okay, next we're going to talk about solving equations with fractions using the multiplication and division properties. Okay, so what you want to look at here is you want to see what it is that is happening with the x. So the 8 is multiplied, so the opposite of that is going to be divide. So I'm going to write this out so it's a little bit bigger. 8x equals 32. So what am I going to do with this to get the x by itself? I'm going to divide by 8 on both sides. And I get x equals 32 over 8. Well, that goes in perfectly. 32 divided by 8, remember? So remember that's just a divide sign. 32 divided by 8 is 4. So how are you going to check that? You're going to check by just saying 8 times the 4 that we got is 32. Is that true? Yes, it is. That one's an easy one to check. Some of the others are a little harder. Okay, so the next one, we've got n over 5 equals negative 8. All right, so what are you going to do to get the n by itself? It's divided right now, so what is the opposite of division, or the inverse of division? Inverse operation is going to be times 5. And if it helps to write 5 over 1, then do so. Over here we don't need 5 over 1, but we can if we want. Doesn't really make a difference. So now we basically have 5n over 5 on the left. So 5n over 5 means that the 5s are going to become 1s, right? And we end up with n by itself on the left. Negative 8 times 5 is negative 40. Okay, so let's check this. Negative 40 over 5 equals negative 8. Is that true? Yes, it is. And that is check. All right, next one. Very similar, but with more negatives, so try this one on your own. So we've got x over negative 7, or divided by negative 7, equals negative 11. All right, so in order to get the x by itself, I'm going to have to multiply both sides by a negative 7 or over 1, however you like to think of it. Doesn't matter. Both of them are negative 7. So the negative 7 over negative 7 becomes a 1. And I get x by itself, which is what I was looking for. And the negative 11 times negative 7 is positive 77. All right, so double check. Positive 77 divided by negative 7 is negative 11, and that is true. All right, solving equations with a coefficient of negative 1. All right, so given negative x equals 7, what is x? So the first method is just do it mentally. Remember that negative x means the opposite of x. So if the opposite of x is 7, then what is x? The opposite of x is 7, then x must be the opposite of 7, right? So x equals negative 7. So you can think of it mentally. All right, with division, you can replace a negative with a negative 1 and divide both sides by negative 1, right? So here we go. We're going to say negative x equals 7 means negative 1 times x equals 7, right? So we can divide both sides by negative 1, negative 1, negative 1. The negative 1s are going to cancel out, and I get x equals 7 divided by negative 1 is negative 7. Okay, so x equals negative 7. Again, the last method is think of it as multiplication on both sides by negative 1. So we've got negative x is the same thing as negative 1 times x, just like we said before, equals 7. So now multiply both sides by a negative 1, which is the only thing we get to do this with. Negative 1 times negative 1 is just 1. So on the left, we're left with x. On the right, 7 times negative 1 is negative 7. All right, so with that, go ahead and try solving number 5. All right, so if negative x is 10, then that means x equals negative 10. If negative n is 6, that means n is negative 6. And I'm doing it the mental way. If you need it the long way, do it with just like we did right here, either dividing or multiplying. I think multiplying is easier, by negative 1. Okay, solving equations with a fraction coefficient. So the goal is to make the coefficient equal to 1, or yeah, make the coefficient a 1. That's what we want, because we want the variable by itself. So remember what happens when you multiply a number by its reciprocal? You're going to get 1, right? So that's the key to solving these. So remember, if you have a 3/4 and you need it to be 1, you're going to multiply it by 4/3, right? The reciprocal. So let's talk about reciprocals real quick. What is the reciprocal of a 1/2? 2/5 and negative 4/3. Pause the video, write those down, and see if you get them right. Okay, so that's what you should get for those. All right. So we're going to also remember to try to check answers by using logic. So remember, when you have something that looks like this, 3/4 with an x next to it, it means 3/4 times x, or 3/4 of some unknown number. So 3/4 of some unknown number equals something. So try to keep that in mind while you're doing these problems. It'll make them just a little bit easier to make sense of. All right, so solve, then check your answer mentally to see if it makes sense. All right, I'm going to rewrite these. So I've got 2/3 times x, 2/3 of x equals 22. Now, how are we going to get rid of that 2/3? We are going to multiply it by 3 halves, which means we have to do the same thing on the other side. Okay, so now the 3's are on top, right? 3 on top and 3 on the bottom, and the 2 is on top and on the bottom, so I can cancel it out, and that's what I was looking for. So I get x equals, now on the right side, remember this is over 1. So what this really is 22 times 3 over 2, right? So now we can think, how many 2's go into 2? 1. How many 2's go into 22? 11. And on top, I've got 11 times 3 over 1. All right, so 11 times 3 is 33. So now let's think about this. Let's write this in English. 2/3 of 33 is 22. Does that make sense? 2/3 of 33 is 22. And you can check it on your calculator too. 2/3 times 33. Okay, so I really recommend checking these mentally and on your calculator. Make sure they make sense. All right, 2/7 times m equals 6. Pause the video and give this one a try. All right, so you're going to multiply both sides by the reciprocal of 2/7, which is 7 over 2. 7 over 2. All right, so on the left, the 7's and the 2's are going to divide out, which is what we were going for. That was the whole point. Equals 6 over 1 times 7 over 2. Now remember, you can treat this as if it were a long bar right here. Okay, so we've got 6 over 2. How many 2's are in 2? 1. How many 2's are in 6? 3. We're left with all 1's on the bottom. 3 times 7 on the top. And so on the top I have 21, and on the bottom I just have 1. So now let's think about this. 2/7 of 21 is 6. Does that make sense? I think so. 2/7 is less than half, and quite a bit less than half. So you can also use your calculator. Put 2/7 times 21 and see if you get 6. All right, one more. Give this one a try. Oh, nope, there's 2 more. Give both of, no, I think there's 3 more, actually. We're going to give all these a try. So give these next 2 a try without me, and then come back and check your answer. Okay, so for this first one, you want to multiply both sides times 4/3. 4/3. 4's are going to cancel. 3's are going to cancel. And we get P equals, now I've got 15 over 1. What happens here? I've got how many 3's go into 3? 1. And how many go into 15? 5. So 5 times 4 is on top. And that is 20 over 1, which is just 20. So now 3/4 of 20 is 15. Is that true? Try it on your calculator and logically. 3/4 times 20 is 15. And that does make sense. All right, 2 more. Give these a try. All right, so what is the reciprocal of -1/4? Hopefully you know that that is -4 over 1, right? So -4 over 1 or -4, right? It means the same thing. 4 over 1, 4, it doesn't matter how you write it. So I'm just going to write it as 4 over on the right side. All right, so here I'm going to say the 4's are going to divide out, and then the negatives become positive because a negative times a negative is a positive. So all I have left is 1's and y. So on the left I have y equals 2 times -4 is -8. So let's check it. 1/4. Let me make that negative because that's a little weird. So -1/4 times -8 equals 2. Is that true? Yes, it is. All right, last one. 2/5 times x equals -4. So the reciprocal of 2/5 is 5/2. I'm going to do that on both sides. While I'm at it, I'm going to put it over 1. I see that my 5's and my 2's cancel out. I get x equals. All right, so now I'm going to have to reduce this. I see a 4 and a 2. They're both even. So how many 2's go into 2? 1. How many 2's go into 4? 2. And I'm left with -2 times 5 on top, which is -10. So let's see if that makes sense. 2/5 times -10 equals -4. So 2/5 of -10 is -4. That makes sense. Okay, I think that is it. Yes, thank you for watching.